Hello everyone, welcome back to my channel. This is a continued part of the code systems in digital electronics. Now we are going to see about the gray code conversions. In this video, we are going to learn about gray code, which is also called as reflected binary code, where it is one of the most widely used codes in digital systems because of its unique property like between two successive numbers only one bit changes. This helps in reducing the errors during the transitions. The major property of this gray code is the gray code is non-weighted code. Unlike the BCD, you don't depend on digit like 8421, 5421 and 2421. It won't depend on all those things. Successive numbers differ by only one bit, so it is called as unit distance code. This gray code is originally designed to prevent the errors in mechanical switches and rotary encoders. This is the main property of this gray code. In order to convert the binary numbers to gray, we need to perform XOR operation. So if you're not aware about this XOR operation, you're going to learn in the further part of the digital electronics videos. So for the simple, let's see how this XOR works. In the two inputs like 0, 0 and 0, 1. This is the one input and this is the other input. In XOR, if the inputs are same like 0, 0 or 1, 1, the output will be 0. If the inputs are differ like 0, 1 or 1, 0, you are going to get like output as 1. So for 0, 0, you're going to get 0. For 0, 1, you're going to get like 1. Same for this 1, 0 and 1. If the inputs are differ, we are going to get 1 as an output. If inputs are same, then we are going to get 0 as the output. We use this pattern while converting binary to gray. Let's take an example for this binary to gray. Let us take the value like 1, 0, 1, 1, 0. This is the binary. We need to convert this binary number into gray. So we need to XOR all these numbers. 1 XOR. This is a symbol for XOR. Plus surrounded by circle. 0 XOR 1 XOR 1 XOR 0. Initially, we should write 1 directly. Let's write this is binary. This is gray. First, we need to write 1 as it is. While writing the second term, we need to XOR 1 with 0. Here 1 and 0 are differ. So value will be 1. Next, while writing the third term, we need to compare the second and the third one. Here 0, here 1. What we get? We are going to get 1 because both the values are differ. Next, let's write the other. Let's compare third and fourth term while writing the fourth digit. Here we have the same digits like 1 and 1. So we need to put 0. Because as a basic XOR operation, by any chance we got the two inputs same, then the output will be 0. So by writing the final, we need to compare fourth and fifth. This fourth and fifth digits are differ. So we got 1. So this will be our gray code for this 10110. So let's see how the values from 0 to 10 will look like when we convert from binary to gray. Here we have the decimal numbers from 0 to 10 and the corresponding binary values are also here. We need to perform the XOR operation for all these binary values. First, we need to write the initial value as it is, then XOR 0, second digit, XOR third digit, XOR final. So here we need to write the initial number itself. 0 XOR with 0, the same value we are going to get like 0 here. For 0 XOR with 0, it is 0. 0 XOR with 0, it is 0. For 0, 0, 0, 0, we are going to get 0, 0, 0, 0 as gray value for this binary value. So for this 3001, 0 XOR with 0 and XOR with 0 XOR with 1. Here initial value will be same. 0 XOR with 0, it is 0. 0 XOR with 0, it is 0. 0 XOR with 1, here the digits are differ. So we are going to get 1 here. Now perform for 2. 0 XOR 0 XOR 1 XOR 0. 0 will be here. 0 XOR with 0, it is 0. 0 XOR with 1, it is 1. 1 XOR with 0, it is 1. Now let's move for 3. 0 XOR 0 XOR 1 XOR 1. 0. 0 XOR with 0, 0. 0 XOR with 1, 1. 1 XOR with 1, it is 0. Now let's move for 4. 0 XOR with 1 XOR with 0 XOR with 0. 0 XOR with 1, sorry, let's write 0 here. 0 XOR with 1, it is 1. 1 XOR with 0, it is 1. 0 XOR with 0, it is 0. Now let's move for 5. 0 XOR with 1 XOR with 0 XOR with 1. 0 will be here. 0 XOR with 1 is 1. 1 XOR with 0, it is 1. 0 XOR with 1, it is 1. Now let's move with 6. 0 XOR 1 XOR 1 XOR 0. 0 will be here. 0 XOR with 1 is 1. 1 XOR with 1 is 0. 1 XOR with 0 is 1. 0 XOR 1 XOR 1 XOR 1. 0. 0 XOR with 1 is 1. 1 XOR with 1 is 0. 1 XOR with 1 is 0. For 8, 1 XOR 0 XOR 0 XOR 0. 1 XOR with 0 will be 1. 0 XOR 0. 0. 0 XOR with 0, it is 0. Then for 9, 1 XOR 0 XOR 0 XOR 1. Here it is 1. Then 1 XOR with 0 is 1. 0 XOR with 0 is 0. 0 XOR with 1 is 1. For 10, 1 XOR 0 XOR 1 XOR 0. 1. 1 XOR with 0 is 1. 0 XOR with 1 is 1. 1 XOR with 0 is 1. So this is our gray values for this binary values from 0 to 10. Here you can observe, you only see 1 bit variations from each numbers to each. From 0 to 1, you see 1 bit is changing. From 1 to 2, only 1 bit is changing. Here 0, 0, 0, 1, here 0, 0, 1, 1. From 2 to 3, you can observe only 1 bit changing. And same for every successive numbers. Now let's move with gray to binary conversion. This gray to binary conversions will follow the same XOR operation but slightly in different manner. Let us take an example. Let us take the gray value as 11101. This is our gray value. For the conversion of gray to binary, write the gray value first. Gray will be 1, 1, 1, 0, 1. Let's write binary here. As usual, same for the first. We need to write the first digit here. We need to perform the XOR operation with the initial result what we got with the second term of the gray. So XOR this with this and we got the second result. What is the XOR with 1? 1 XOR 1. We are going to get 0. The third number, we should not consider this previous second value. We need to consider previous result. So 0 XOR with the third digit. We get 1. For the fourth digit also follow the same rule. Consider the third result XOR with the fourth integer of the gray to get fourth result. 1 XOR with 0 is 1. Again XOR this result with the final digit of the gray. 1 XOR with 1 is 0. So final binary value will be, let's make a chart from 0 to 10 for this gray to binary, okay? So now let's convert these gray numbers to binary. So let's move with this 1, 0, 0, 0, 1. Let's write the first digit as it is 0. We need to XOR the first result with the second value of the gray. 0 XOR with 0 is 0. Then second result with third digit of the gray. 0 XOR with 0 is 0. Then 0 XOR with 1, it is 1. Then let's write for 2. Let's write 0 here. 0 XOR with this 0. What we get? 0. Then second result with the third number of gray. 0 XOR with 1, it is 1. Then third result with the fourth value of the gray. 1 XOR with 1 is 0. Let's move for 3. Let's write the initial value as it is. Then 0 XOR with this 0 will be 0. Second result of the binary with the third number in the gray. 0 XOR with 1, it is 1. Then third result of the binary with the fourth value of the gray. 1 XOR with 0, it is 1. So let's move with fourth decimal number 4. Let's write the initial value as it is. Then 0 XOR with 1 is 1. 1 XOR with this 1 will be 0. This 0 XOR with this 0 will be 0. Again, let's move with decimal number 5. Initially it is 0. The first result of the binary with the second value in the gray. 0 XOR with 1 is 1. The second result in the binary XOR with third value in the gray. 1 XOR with 1 is 0. Then this result with the final digit in the gray. 0 XOR with 1 is 1. Let's move for the decimal number 6. Initially we write as it is. 0 XOR with this 1 will be 1. 1 XOR with this 0 will be 1. 1 XOR with this 1 will be 0.
Now we got all the values from 0 to 10 here. If you have any doubts, just put a comment in the comment section. Thank you for watching. Let's see in the next videos.